Hello everyone, welcome again to our summer practice program. In this video, I will go over problems in quiz 1 of the Pre-AMC session. All right, so first let's look at question 1. So the problem says, we have a 5-digit number, 1x, 2x, 3. It is divisible by 9. So what you need to figure out is what is the missing number x. Okay, so here what we need to use is the so-called divisibility test of 9. So what is the divisibility test then? So those things, they provide a shortcut to tell whether a number is divisible by some integers like 9, 3, 5, and 4, and 6, something like that. Okay, so especially for 9, the divisibility test says a number is divisible by 9 if and only if the sum of the digits is divisible by 9. So let me write down. Okay, so here's what the test says. Okay, so a number is divisible by 9 if and only if, so it's the same, the sum of its digits is divisible by 9. All right. Okay, so then for this particular number, so we say, all right, we just need to look at its digits. So 1x, 2x, 3. So I look at the sum of its digits. So it's 1 plus x plus 2 plus x plus 3. So I want this one to be divisible by 9. Okay, so what is this? So 1, 2, 3. So you put together. So this is 6, right? So 6 plus 2x is divisible by 9. Now, in order for this one to be divisible by 9, we have, let's see how many possible choices we have. We can have, this is, okay, so this one, it could be 9, or this is 18. Well, you say, oh, why not we go up 27? The 27 is too large, it's impossible, okay? All right, so then if you look at the two cases, you see, okay, 9 is impossible. You cannot have x because this is even, you cannot get 9. So the only possible is 18. So I have 6 plus 2x equals to 18. From here, I quickly get x equals to 6, okay? So I get the final answer is the 6 is the only digit to make this 5-digit number to be divisible by 9. So here the key is the divisibility test. So let me say again, so the divisibility test for 9 says a number is divisible by 9 if and only if the sum of its digits is divisible by 9. All right. Now let's look at a problem 2. So problem 2 says if we define this kind of rule, right? So it's A star B equals A squared minus B squared. So this is just the definition. So you kind of define the operation. All right, so by this rule, I have 5 star 4, right? Okay, so it's just 5 squared minus 4 squared, which is 25 squared minus 16, that is 9. So here's squared, let me remind you, so A squared means it's A multiplied by A. Okay, so then for this, you get a 5 squared, 4 squared is 25 and 16, so this gives us 9. All right. Okay, next, let's look at a problem 3. So problem 3 is a problem about probability, okay? Well, first of all, let's recall that what is the general formula to calculate the probability. So the general formula, so probability equals to, it's a fraction. So probability itself is a fraction. Okay. Well, it is just the ratio. It's the ratio between. So here what we have is the denominator is the number of total cases, or we say the entire collections of all possible scenarios, and the numerator is the number of valid cases, right? Valid cases. All right. So now let's look at our situation. So here we have, 2 dice, and we roll 2 dice. Okay, so then we get a pair of numbers, right? So from 1 to 6. So this one is from 1 to 6. This is also from 1 to 6. Okay, all right. So if I have a pair, right? So if I have a pair, Okay. So if I pair, so the total number of different scenarios. For this one, I have 6 possibles, right? And for this, I also have 6 possible values. So the total number will be multiplication. You multiply them together. So this gives us 36. So this is the multiplication principle, right? Okay, so now, before I move on, so let me say a little bit about the multiplication principle. Now, another way, if you say, okay, I don't know the multiplication principle, then you can also figure this one out just manually. So, okay, so the first one, I have 1, 2, 3, 4, 5, 6 choices, right? So this is for the first one. And then for the next one, this is also 1, 2, 3, all the way to 6. And this is also 1 all the way to 6. And this is 1 to the 6. This is also 1 to the 6. So this is also 1 to the 6. And this is also 1 to the 6. So this for the second one. Now, of course, what you see from here, you get 6 times 6. You have 36 different pairs, right? So what is the multiplication principle? So what is the multiplication principle? Multiplication principle says this. Say I want to have, I want to finish a task, right? So a task has several steps. So I'm going to explain what is the multiplication principle. Now you have said you want to finish a task, and the task has several steps. Let's say you have 2 steps. So then you have to go from 1 to 2, and from 2 to 3, okay? So say from 1 to 2, you have 3 different ways to finish it, right, to accomplish that step. And from 2 to 3, you say, okay, I have 4 different ways to finish the second step. Then the total number of ways, right? So I get the total number of ways is 3 times 4 equals 12, right? So you can consider this as the scenario. I want to go from position 1, city 1 to city 2. City 3. So first I have to go to city 2, and from city 2 to go to city 3. Right, from 1 to 3, 1 to 2, I have several different ways. Let's say you can go through, say, the highway I-5 or highway I-405, right? So that's around highways around Irvine, California. And then you can also go from, let's say, from 2 to 3. You also have several different ways. So then if you combine all different ways, it's, of course, it's sheer multiplication, right? You do multiply because you go 3, and then each one you have, you have 4 choices, so 3 times, which is 12. All right, so this is the general statement for multiplication principle. Let me repeat. So say you want to finish your task. The task has several steps, right? Each step have different ways to finish. So the total number of ways is you do multiplication. So right here, you see, okay, I have 2 steps, right? I have to first, I have to choose the number for the first die, and then I choose the number for the second die. And each one, I have 6 possible values. So that's why I do the multiplication, which is 36. All right. Okay, so this is the multiplication principle. Now, I'm going to erase that out and move to figure out the value cases. So let me erase this multiplication principle. All right. Okay, so now I need to figure out what is the number of valid cases. Okay, so valid cases means, according to this problem, is the pair, the sum of 2 values is no less than 9, right? So we can do case works. So we have the first value, right? First value I can do I do this so-called case works, right? So I do different cases, depend on what is the value for the first one. So the first one could be 3, 4, 5, and 6. Now you may wonder, wait, why it's not 2 and 1? If it's 2 and 1, regardless how you do it, it's not going to be no less than 9, right? Okay, so if it's 3, so the second one could be 6, this is 5. If it's 4, could be 5 and 6. If 5, could be 4, 5, and 6. If it's 6, could be 3, 4, 5, and 6. All right, so let's see how many different scenarios we have. We have, this is 1 pair, this is 2 pair, this is 3 pair, this is 4 pair, this is 3 pair, and this is the 4 pair, right? Now you add them together. I add all of them together, I get in total, there are 10 valid pairs, right? So I have 10 valid pairs. Okay, all right. So then I just put everything back to the probability. So the total number of cases, we calculate this one equals to 36, right? And then we calculate the total number of valid cases, which is 10. right? So which is 10. Okay, so this is the total number of cases, which is 36, right? Okay, so then the probability is just a fraction. If we move, if we try to let's simplify it. So this is 10 over 36. Now we can divide a common factor 2 from the denominator and numerator. So it will be 5 over 18. So 5 over 18, the fraction. So this is the probability. Okay, so probability, as first step, you can understand this is just a fraction. So it is the total number of, okay, so you first calculate the total number of cases, right? And that use that one as the denominator. And then you calculate the total number of valid cases, or those cases you're looking for. But use that one as the numerator. And then you just take the fraction, and that number is the probability. All right. Okay, now let's look at the next problem. The next problem says how many 4 positive integers A, B, C, D. We specify that okay, so let me put it right here. So we have A, B, C, D, right? So this is 4-digit number. Now we want to so here we have some requirements. So the first one says the 1,000 digit A and the 10th digit C, they're all even numbers, all right? So we want this one is even number, and the one this is also even number. All right, so then also we want 100 digit B and D, they're odd numbers, okay? So we want this guy to be odd number and odd number, all right? So here E represents even number. Okay, so the third one says the number is divisible by 5. So now we need to recall what is the divisibility test, right? So divisible by 5, so let's recall the divisibility test for 5. All right, so a number is divisible by 5 regardless of how many digits. The divisibility test says if and only if the last digit is either 0 or 5. So okay, so this one is either 0 or 5 for the last digit. Okay, so this is the divisibility test for 5. Okay, so you combine this. So we say, well, we want 0 or 5, but meanwhile, we know it has to be an odd number. So that means the last digit has to be 5, right? So we get the last digit is 5. Okay, so we determine the last digit has to be 5. That's what we have. Okay, if you combine all those information. Now we use the multiplication principle as we mentioned before. So we use the multiplication principle, right? Okay, so you can consider this as a test. We have 3 steps. The step 1 is you need to determine the value A, right? And then you need to determine the value B, and then you determine the value C. Okay, so how many choices do we have for A? So first of all, let's list out even numbers. So even numbers is 0, 2, 4, 6, and 8, right? All right, so those digits. And then we have odd number. So odd number is 1, 3, 5, 7, and 9. All right, so let's look at how many possible values do we for A. Because A is the leading digit, it cannot be 0. So A could be, A has 4 choices, right? So this has 4 choices. 4 choices. Now, how about for B? B could be anything from this collection of odd numbers. So this has 5 choices for B. All right, so how many choices for C? And C has no restriction as long as it's an even number. So we have 5 choices for E. All right, so then by the multiplication, D is already given is 5. So by the multiplication principle, so multiplication implies the number is the total number of valid cases is 4 multiplied by 5 and then multiply by 5. So here we should do is the multiplication, not addition. So this is 100. Okay? It's 100. All right, so this is, again, it's a typical application of the multiplication principle. So it's if you have different steps to finish a test, right? If they together form the test, form the whole mission. And you have different possibilities for each step. What then the total number of ways to finish the whole thing is you do multiplication, not addition. All right. Okay, so now let's look at problem number 5. So number 5, so this is something about a fraction. You basically simplify a fraction, right? All right, so let's look at this. So if we have this n over 10 equals to, so first n over 10 equals to this, 2 over 5. And we see this guy is 5 plus 2 times 2. So okay, so this guy is also 2 times 2 in order to get rid of the 2. All right, so then I quickly get the n equals to 4. Now we look at the next one. Okay, so this is also equals to 2 over 5. Okay, so I have 6 over n equals 2 over 5. Now the 6, let's look at the numerator. So numerator 6 is 3 times 2. So this one is 3 times 2. Okay, so accordingly, this guy has to be 5 times 3, right? 5 times 2 in order to get rid of this common 3. Okay, so then we get this n equals to 15. All right, and this tells us n plus n equals to 19. It's 19. Okay, so this one has the simplification of fractions. All right, now let's look at problem number 6. So this one is a multiplication of a past AMC 8 problem. So in the original AMC 8 problem, the problem did not provide the 100. It just says Nancy has a certain number of marbles and the others are the same. All right, so here for convenience, I just put this concrete number. It's not really needed for our problem if you just want to find the percentage, right? It's the question about the percentage. All right, so you don't really need this 100, but for convenience, I put it here. All right, so anyway, so let's do it. Okay, so let's repeat the setup. So Nancy has 100 marbles. So this is Nancy. And Nancy gave, so first of all, she gave 20% of them to her friend, Pedro. All right. Okay, so let's figure out what is 20% of 100. Well, it's obvious, it's 20, right? So 20, so she gave 20, basically she gave 20 to her friend. Okay, so that's 100 times 20%. 20% equals to 20. So here I want to remind you, so percentage is a special fraction, right? So 20%, just 20 over 100. And okay, so 25% is 25 over 100, and 10% is 10 over 100, right? So percentage is just special fraction. Okay, so after that, after this, Nancy has 80 left, right? So 80, so Nancy has 80 left. Now next time she gave, from the remaining, she gave 25% to another friend, okay, Ben. Okay, so now we need to figure out what is the 20% of 80, right? So I do it. So it's 80 times 25%, right? 25%. Okay, right. So what is 25%? So 25%, as we said, this is just 25 over 100, which you simplify just 104 because 100 equals 25 times 4, right? So we say it's 1/4, okay? So this is just 80 times 104, while 104 of 80, so this is 20. So we get it, this is, again, it's 20. Okay, so which means gives another 20 to another friend, Ben, so this is 20. Okay, so after this, let's see. So after this, the next one, so we have 60 left, right? 60 left, Nancy. 60 left. Okay. All right. So then give 10% to her brother Jamie, right? 10% from Jamie to Jamie. So 10% is out of the remaining 60. Okay. So let's calculate the 60%. So this 1, this 2. All right. Okay. All right, so now let's calculate 10% of 60. So 60 times 10%, right? So that's 60 times 100 over 10, but 100 over 10 is just 1 over 10. We simplify this, right? So the 60 times 1 over 10, and that is simply 6, right? So it's gives 6 to his brother Jimmy. So what is left? So finally, what the percentage has given for herself, so give away. So finally, so what do we get? So at last, right? At last, Nancy has 54 left. right? So 54 left. Okay, so originally she has 100, right? So it's go from originally she has 100, and then 64 left. So what's the percentage she has given away? So the percentage is 54 over 100, right? The fraction. But here, because the denominator is already 100, so you just get it for free. So this is 54%, right? Okay. So here, what you should pay attention is, first of all, you need to know what a percentage is. As I said, it's basically a special fraction. The denominator is 100. And then you need to be careful, like when the next one we do percentage is percentage of those remaining things, right? So then you do reduce to a fraction and do multiplication. All right. Okay, next. We are looking for, so what is the sum of all? We need to find all positive two-digit integers, such as a remainder of 1 when divided by 9 and remainder of 2 when divided by 5. So which means it has to satisfy two things. One is has remainder of 2 when it's divided by 9, and the second one is when remainder 1 when divided by 9, and the second one is remainder 2 when divided by 5, right? Okay, so for remainder, if some of you don't know what remainder is, let's look at this. So 10 divided by 4, right? Okay, so I have 2 here, so this is 8, right? So there's a leftover. This leftover, this guy is called a remainder, right? So this guy is called a remainder. And this one is called a quotient. Quotient. Okay, 2 is called quotient. And 10 is called a dividend, and 4 is called a divisor, right? So those are just terminologies. All right. Okay, so the hint says you first figure out, so first you write out all the numbers. Okay, so at first you ignore another condition that when divided by 5, the remainder 2. We just focus on, so step 1. Step 1, so we just find all numbers, right? All numbers that has the remainder 1 when divided by 9, right? So we just write it out, okay? All right, so for 2 digits, so we start from the first one, all right? So we start from the first one. So the first one is, because it's 2 digit, so we have the divided by 1, so the first one is 10, right? So 10 2 digit, when divided by 9, the remainder is 1, right? So the next one is just 19, you just keep adding 9s. So the second, let me write out, so 28, right? 7, 46, 55, 64, 73, 82, right? And then 91, right? So these are all the 2 digits numbers that when they are divided by 9, the remainder is 1. All right, so then so this is step 1. And step 2 is we need to pick those that has remainder 2 when divided by 5. So what you can do is you say, okay, I look at these numbers and I figure out those right ones, right? Okay, so here what we have is, first of all, is 34. This one is valid. When divided by 5, the remainder is indeed 2. And what's the second one? The second one is 82. This one is also valid. And divided by 5, the remainder is 2, right? Okay, so all the others are not valid. All right, so I just find the 2. So the total sum, 37 plus 82, this is 119. So we get this 119.